Good morning, everyone, and thank you for joining us today at the Introduction to Energy Monitoring for Energy Savings webinar. My name is Beth, and I will be hosting today's webinar, which means I'll be monitoring the chat window and conducting some survey polling at the end of the webinar. Today we'll be covering highlights from our half-day seminar, Energy Monitoring for Energy Savings. Our hope is that after today, you'll be able to understand some of the fundamentals and basics of energy monitoring and apply them at your facility to help you save both energy and money. We also want to thank our sponsors today, the Energy Trust of Oregon and Northwest Energy Efficiency Alliance. We know from our customer feedback that they appreciate we're aligned with these two organizations, which helps eliminate any confusion regarding energy efficiency and renewables. Before I introduce our presenter for today, I'd like to show you some of the tools you'll be using during the webinar. To the right of your screen, you'll see several windows: the participants window, the chat window, and at the end of the webinar, you'll see the polling window. If you have any questions during the webinar, you can submit them to me, the host, through chat, and the instructor will answer them at the end of the webinar. Because this will be an informal session today, if you'd like to share an example or you'd have a question you'd like the instructor to address immediately, feel free to use the raise hand icon, which you'll see at the bottom of the participants window. At the top left corner of your screen, underneath the Quick Start tab, you'll see several tools, which I'll underline here with a red marker. Your far left, you'll see an arrow tool, and then a text tool, and then there'll be a marker. And the instructor will ask you to use these on various slides, so you don't have to worry about them until he instructs you to do so, but that's where they're located. And now I'd like to introduce today's presenter, Will Miller. Excuse me. Will is our PGE's Energy Information Services Specialist. Will specializes in providing operational and analytical support to PGE customers who monitor their energy use. His area of expertise at PGE is in energy information services and web-based power quality monitoring. Will is also a member of the Association of Professional Energy Managers, and he has a BS from Portland State University. So without further ado, I would like to hand the presentation over to Will.
My name is Will Miller, and I'm the presenter for today. Now that you've heard a little bit about me, let's find out a little bit about you. With your arrow in the annotating function, can you place your name next to the option that best describes you? This way it gives me a better idea of the demographic we're serving. So if you could take the arrow and then put it next to either facility manager, sustainability manager or coordinator, energy manager, maintenance manager, HVAC technician, electrician, finance, jack of all trades, or consultant. So take a minute and just kind of show me where you guys are at.
And just as a reminder, those tools that Will is talking about are in the far left-hand corner of your screen underneath the Quick Start tab.
Okay, good. We got a few participants out there. That's good. So, all right. Well, now that we know who you are, let's find out why you're here. So maybe you have a mandate for energy reduction, or maybe you need to benchmark your facility or want to prove savings for an energy efficiency project. Maybe you need to track and monitor energy for LEED, which is Leading Energy Efficiency by Design Standards. Or maybe you're interested in the whole sustainability aspect of it all. Maybe you use Energy Star, which is a benchmarking tool provided by the EPA, which has a lot of different ways to compare your buildings to others and get an Energy Star rating. And maybe if you have another reason why you're here, yeah, feel free and mention it in the chat. We're always interested. Okay, today's agenda. We're going to focus on 3 key areas. First, we'll talk about the plan. And we'll get to the plan a little bit more in the next slide. But then secondly, we'll talk about utility terms. We'll cover these and show you how we need you to understand how energy is measured. Third, we'll be covering energy monitoring for energy savings or operational-based savings. So an example of this might be, instead of changing out equipment, you'd be looking for ways to change your operating habits to be able to get energy savings. This may be as simple as, having lights turned on and off, but obviously it's going to be more complicated than that. But so this is the whole plan, but we're going to focus on 3 areas, such as first, collecting and tracking your bills up here. And next, we're going to be creating load profiles, maybe not necessarily your load profiles since yours aren't here, but basically we'll focus more on interval data and where to get it and how it's collected. And then we'll spend some time on reviewing some load shapes. We have some examples set up, and just so you get an idea of what that's all about. So now that I've mentioned getting utility bills is important and that you should have a plan, maybe your group might want to sit down and have a meeting, and you'll discuss bills and metering, and you might want to discuss where your meters are, what type of metering you have, options for meter communication, which is definitely important. Then you get a urgent call from your supervisor or whoever with an urgent situation. I guess room 22 is too cold, and the meeting is interrupted, and your plan pretty much goes out the window because the urgent situation. And this makes your plan pretty much, all forgotten. But, if I can urge you to not let stuff like that happen, make sure you follow through with your plan and, get your bills and plan to discuss metering and all your options. This is just definitely a good place to start. Next, we're going to go on to some energy terms. We're going to shift away from the plan a bit so we can review these terms and just so you can better understand how energy is measured. I don't know, this may sound simple, but energy, denoted in kWh, is the ability to do work measured in kilowatt hours, kWh. 1 kilowatt hour is the energy expended by a 1,000 watt load over the course of an hour. So an example of this would be a 100 watt light bulb would be on for 10 hours, which equals 1,000 watt hours, in turn equals 1 kilowatt hour. So the next energy term we'll talk about, and you'll definitely see on your bill, is demand. Demand, also defined as real power, is the rate at which energy is being consumed. It is measured in kilowatts, kW. Utilities refer to demand as a value reference to an hourly usage rate. So to make this a little more clear, let's say if you use 25 kilowatt hours in a 30-minute period, you would have had a demand of 50 kW during this period. It's kind of like driving and the rate of speed. If you drive for a half hour and went 25 miles, you had to be traveling at least 50 miles per hour. So hope that kind of puts it in perspective a little bit. Like I said, that was just one example. Okay, now we're going to go on and look at an example of a electric bill. This is pretty much the basic summary page, which tells you the basics. Your basics being amount due and when your bill is due. Another important piece over here is how many kilowatt hours you used in that billing cycle. And one more important one that I think is very important is your meter serial number. If you're wanting to sign up for any kind of energy information service, you're going to need to know your meter number and basically what it serves. You might be a good idea to have your electrician check out if you have multiple meters. Check out which meter covers what area of your building. It's just a good idea, and basically let you know what you need to know when you start measuring. Okay, this next page is the detail page. Um, there are many charges on here, but of course we won't cover them all. But as you can see, the corresponding values of the terms we just covered, kWh and kW, are the largest or most critical part of your bill. You got first the largest, the kWh, that's your kilowatt hours, that's what you're charged, and then your demand charge is right underneath it. Now that is your peak demand. Now one other charge you might want to pay attention to is this one down here, facility capacity charge, and that is related to the demand charge by, this takes the average of the two highest peak demands you've had in the past year. So those three highest charges definitely make it, so you might want to pay attention to, obviously, amount of kilowatt hours used and, know about how high your demand is. Okay, this next part of the bill gives us even more detail, even more charges and adjustments, but a lot of them really aren't important or pertinent to this seminar, but I do encourage you to look at the definitions on the back and just to get more information for yourself. Also on this page is a graph of your energy usage. That is right here. And you have average kilowatt hours per day, and basically it's a 13-month graph comparing each month's load. Now, first thing that I would look at is obviously January. This is this month right here, and look at last year's January. And another thing, when you're comparing this month to the same month of last year, you can also look up here, and it compares the values, how many kilowatt hours you spent both times. So this, like I said, that's just a good thing to pay attention to on your bill, especially when you're looking to improve energy use, not exceed it. You're probably wondering, okay, why are we spending so much time on bills, and who has time for all this? We consider this a very important part of the plan. We think it's a good idea to get a copy of your bill, enter the kilowatt hour data in a spreadsheet, and repeat this every month for as long as you need it. Obviously, you can dig through files to find bills, but in case you don't have your previous bills, your utility may provide access to them. I know PGE's website has a page where you can log in with your customer information and set up an account. And then after that, you would group all of your meters and bills together, all of your accounts, and then download that bill information to a spreadsheet. And in case you're wondering, this can be found at portlandgeneral.com. Okay, hopefully this isn't overwhelming you so far. This is just the basics. We're getting started, but we do feel, like I said, paying attention to the bill is extremely important. So even though we've tackled the first step in the plan, it's very important. Like I said, you'll probably hear this will probably be reiterated several times throughout the webinar, but collect and track your bills, and if you do anything else or don't do anything else from the webinar, at least track and locate your bills. Like I said, this is a big part in the first step of the plan. Okay, now we're probably getting to what everybody's been asking about. What is interval data? Um, Interval data is energy usage data that is time-stamped in intervals. Technically, your monthly bill is interval data, but obviously it's less than desired, especially when you have only 28 to 33 days comparing them on the month and the billing cycle. The data is much more meaningful in intervals of 1 hour or less. 15-minute interval data is probably the smallest increment you'll need and the most helpful. Now you're wondering, how do they get the interval data? Well, PG has smart meters out there installed in the field, and these electric meters, they have a memory that collects the interval data and then exports it out through several different means. We have some smart meters that communicate to a communication server where either through cell phone, radio, pager, phone line, those are all great means of exporting or transmitting the interval data to the communication server so we can get it into our system. Some of the meters out there are in non-ideal places and can't communicate, so we then rely on meter reader downloads to collect those. You're probably wondering why the gas meter is shown here. We do have some customers signed up with our program that monitor their gas. They rely on phone lines as well, and then they FTP their data to our collection site and is then to the computer via browser. So after the gas meter, there is the submeters. You're probably wondering, okay, what's that all about? Well, submeters are usually an aftermarket product or a data logger that monitors a smaller subsection of your primary meter. We have several customers doing this and then using our tools to monitor that submeter data. So basically, after all the meters get the data, like I said, they transmit out to the communication servers and then to our data collection system, which we call the MDC, Meter Data Consolidator. And then from there, it gets transmitted to the internal or external internet server. Also, we provide weather data for our services, which is provided by the National Weather Service. That also goes to the internal or external server. And then from there, it exports it to your computer and via browser or software and software tools that view and collect the data. You may have heard of Energy Expert or eManager. Those are our two programs that we offer. However, you do not have to buy these energy information services to continue to receive your current electricity service from Portland General Electric. eManager and Energy Expert are just two that are out there, and there are many others like this, so we are not the only game in town. Okay, so now that we've learned a little bit about interval data, at least where it comes from, what is the easiest way for you to obtain interval data? So if you wouldn't mind, if you could take your annotating device and mark the answer which you think fits the question the best, please feel free and do so. We'll take a minute or so. All right, we got a lot. All right, we got some good people on the right track. So, yep, you guessed it. Look at your electric bill. Start with your bills. That's, like I said, it's a constant theme throughout the webinar. Just to reiterate the answer one more time, we have this example from the bill seen earlier. this is interval data only in monthly intervals. And even though it's a broad time frame, it's still enough to start asking basic questions. Basic questions, you know, just by looking at this graph, you'd be asking, okay, why is November and December the lowest months? So why are those two the lowest? It could be maybe they have gas heat. That's one question. It's a possibility. Also, why is January and February higher than December? So why are these two higher? Could they have maybe extra ventilation or more outdoor lighting during that time? I don't know. You know, looking at patterns is what's essential here. One thing I should probably mention the interval data is that it won't solve all your building's problems. The data is just an indicator of things that need to be interpreted. When you first start looking at interval data, it'll give you more questions and things to investigate than answers. But at least it'll give you a reference or a basis to start looking. Okay, next up, this section is going to be what I like to call the anatomy of a load shape. Now that we have a general idea about interval data, let's take it one step further into a load shape. Instead of a year time frame, let's go down to the interval data in a time frame your building would benefit most from, a 24-hour period. So hypothetically, let's say I have a building, and in my building example, I have a base load made up of contributors such as security lights, a security system, exit lights, outdoor parking lot lights, computers, refrigerators, a ventilation system, a fire alarm system, heating and cooling system, a time clock, elevator controls, a building management system, and like I said, this all put together is about 100 kW base load. So what I'm going to do is basically draw a load shape of what my building's typical day would be, and then explain all the components to it. So, like I said, my base load is at 100, and then from about 1 a.m. to 5 a.m. is pretty flat, and then the lights come on, and then right after that, between 6 and 8, the outdoor lighting goes off, and then right around 7 o'clock, that's when the HVAC starts up and everything's humming, and you get to the top of your load shape. And the rest of the day, while people are working, your load pretty much evens out till about close to 5 o'clock. At that time, you have a chiller come on line, and usage goes up a bit. And then right after around 5, that's when people start leaving, things getting shut down, and your usage starts to drop. Now you're pretty much down about your base load. However, you got to consider your outdoor lighting coming back on, and then also when your cleaning crew leaves. So basically, that would be the load shape of my building. I just kind of wanted to get you thinking of things the things that happen throughout the course of the day. You know, what time people come in and leave the building. When do outdoor lights go on and off? When does the HVAC system come on and off? What are the typical times that miscellaneous equipment go on and off? These are all just good questions to think about and try to apply them to your own scenario. And speaking of that, now we're at another audience participation part. Think about your building or a fictitious building, and think about all the attributes, and then use your annotating device to draw your own load shape. So we'll take a few minutes, and so go ahead with your tools up at the top, and start at your base load, and think of all the things that happen throughout the course of the day, and draw your own shape.
And Will, for the audience's benefit, I just drew an arrow to the tools that you'd want to use. There's a little highlight marker. You can use that. Just click on it, and you should be able to draw with it. And here, I'll just do an example around the 40 with the blue marker.
Okay, perfect. Nice. Okay, good. Good. We got some good examples. Okay, great. Very nice. Okay. Well, thanks for doing that. Like I said, I just kind of wanted to get you thinking, you know, uh, what is made up, what makes up your load shape. So, okay, from this, we'll move on to another load profile example. So the next load profile we're going to look at will give you a better understanding of demand over time and its calculation into kilowatt hours. Um, Looking at this down here to the left, you'll see the beginning of the day to about 5 a.m. averages probably about 340 kW. And that goes on for about 5 hours. Now, the bulk of your load shape is a big range, but I'm going to say that it averages at about 1,000 kW. And that usually lasts around 13 hours. And then going back to the decline in the load shape down to the right, it looks to me about an average of 400 kW over 6 hours. So to calculate this into kilowatt hours, you would take the 340 multiplied by 5, which is 1,700, and then add the 1,000 up here times 13, which is obviously 13,000, and then you would add the 400 multiplied by 6 equals 2,400. So adding it all up, you'd have 1,700 kilowatt hours plus 13,000 kilowatt hours plus 2,400 kilowatt hours equals 17,100 kilowatt hours, or 17.1 megawatt hours. Software tools typically calculate this total kWh area under the curve, but like I said, I just wanted to get you an idea of, relation from kW to kWh, and its balance over time. So once you now have an idea of how much energy you use and at what times, some typical things you can find once you have interval data are, we find these are probably the most typical ones we find. Start times in buildings are usually too soon. Evening shutdowns are usually slow or late. Weekend schedules are incorrect. Equipment starting and stopping when no one is around, that's always a good one to find. Controls reprogrammed wrong, we've seen that before. And also equipment failures. So just a few things you can find right off the bat usually, having interval data. Okay, this next example of a load shape is a 24-hour line chart from our eManager program. And so it has, the hours of the day on the bottom and the KW on the left axis. At first glance, I know there's a lot of lines and it's kind of hard to make sense of it all, but each line represents one day of the month. First, look at the chart and notice the daily patterns. So once you've got a good fix on this and see if you can dissect or find any abnormalities you think would make you want to investigate something, and mark this with your highlighter. So if you wouldn't mind, use those annotating tools once again, and go ahead and circle the area of the load shape you think raises a red flag. All right. Okay, those are all good. Um, we'll start with uh, what I thought was a little abnormal. Obviously, the first one everybody thinks is this one over here to the right. Um, you might see that the circled or previously circled area has a bowed decline in load shape over around the uh, you know 8 to 10 o'clock area. This is actually when janitors are working. The yellow and green lines you see um, right here, this is their day off. So this is, Monday through Thursday, and here's the janitor's day off. So that's pretty normal. Um, Whoever circled this part, this is a very good one. Um, this one actually is what would seem to be a somewhat normal day, but not all the way. To me, it looks like they had um, uh, looks like they had the HVAC come on, but no lighting. So we're kind of curious: is there somebody there? Is you know um,
Will, sorry, Will, this is Beth. Could you say which part are you talking about that's circled?
the black area that's circled?
Oh,
Um,
okay.
I have it circled now. My apologies. So yeah, that looks like an extra day of use, and that is actually weekends. And why would that be, up towards 160 kW when it should be, pretty flat? I would call attention to that. Like I said, is someone there on weekends, or is just the HVAC on without lights? I don't know. It's anybody's guess, but that would be a question I would have. Um, so. Other things, why did a few days shut down earlier than others? You know, that's just like I said, the cleaning crew is that that is the most common answer people give, but that's actually just a normal schedule. Our next example, we're going to look at another one. At first glance, there's a ton of lines, and it's hard to make sense of this one too. But if you break it up into sections, you can see some patterns and questions in this one as well. So if you wouldn't mind taking your highlighter once again and circle the parts you think need investigating, go ahead and do so now. Excellent. Okay, we're seeing some good ones here. Good job, guys. Very nice. Okay, I'm going to start over here on the left and work my way to the right. So this pink one circled down here is, you'll see that the line, this is actually at 100 kW when most of the time it's down between 60 and 80. This is actually a school district, and this school district has a computer lab, and um, every so often they run virus checks. And with their virus check software, it turns the computers on and goes through the virus checks. But with this software, you can't remotely turn it off. So basically, once the virus checks were done, the computers and everything just kept going on. They finally remedied this with different software and made it so they could, shut it down after those um, antivirus checks were done. Um, all right, the next one over here to the left. Yes, I think these inconsistent startup times would definitely make me wonder what's going on. Um, the green, forest green circle in the middle, this one here, that is a great one. That is actually a teacher in service day, but you're wondering, okay, well, it's good we know that now, but I mean, you're thinking probably why is there such a large load shape when it's not flat, but it's not a full day's use. That is in teacher in service day. Surprised nobody circled this down here, right in here. This was actually church service used on Sunday. Um, Church comes in and uses it for a few hours on Sunday, but to the layman or the person who doesn't know the building schedule, this would, I think, definitely raise some questions. And then over here on the right side is definitely one I would say too. It looks like they're always inconsistent in shutting the school down. So you guys did really good on that one. And so these are just some more things to look out for. This one is kind of a mess. This one is a distribution center. I won't ask you to annotate on this one. I'll just circle some things that I thought were odd and the few answers we got from the customer. So this distribution center is basically going all the time. However, between 5 and 9, they're shut down on Sundays. That's the only time they're shut down. Again, startup times are very, very, non-consistent. And this area over here would make me wonder what's going on in the distribution center when it looks like there's a stuff that gets shut down or a lull in production, what have you. We asked and they told us this was break time. But I don't know if break time is supposed to be 2 hours, but that was their explanation. So this one I think would take definitely a trained eye from the distribution center to explain all this, because yeah, this one's quite erratic. But like I said, this just kind of illustrates, that it's especially important to know your building's operating schedule. The more consistent you are, the easier it is to track. This next example is another school building, and I've numbered these 1 to 4, and I'll start with number 1. Number 1 is actually a weekend day, but you're kind of wondering, okay, well, why is there 2 days there? This is actually Thanksgiving weekend. I'm not sure what happened or why anything was on this weekend. They could have had a community Thanksgiving, but me not knowing the building schedule, I don't know that. So I would think either something was left on, HVAC was going on. Hard to say, but anyway, the answer they gave us was that was a holiday Thanksgiving. And number 2, you'll see all these spikes go up and down. Some piece of equipment is cycling. For example, we had actually in another school a baseball snack bar that had a heater in it, and some kid or somebody thought it'd be funny to jack up the heater to 90 degrees in the summertime. So every time the temperature would hit 90 and then come back on and off, and it would cycle the whole, all the day trying to keep the temperature up to 90. So when they saw their bill, they called us. We did a high bill check and investigated and found that that's what it was. Somebody had cranked up the heater, and but that by that time that was too late, and didn't help them after they got the bill. So we'll move on to number three. Number three, you're wondering, okay, looks like this is some sort of a dip and lull in usage, and what's that all about? This admin building actually prepares, cooks, and delivers all the meals for the school district. Now, when they get done, you can see through here, they're using their cooking equipment, and then once they're done, they shut off and then go deliver the food. So there is a big lull at lunchtime, like I said, just delivering the food. Just kind of an odd one, that granted it's nothing alarming, but it's something that, they thought, or you would think that, something is wrong there. Number four, again, look how long it takes them to shut down. It's just it doesn't make a whole lot of sense. But like I said, it's best if you know the building schedule. Okay, this next one is a bar chart. It's pretty self-explanatory for the most part. You have your kilowatt hours used on the left and your kW demand on the right. And the blue bars in this graph are the kilowatt hours. And so when I look at this one, this month's worth of usage, you notice a few things. I noticed first and foremost that the date, the 4th of July right here, is almost twice what it should be when it should be a holiday and shut down normally like a Saturday and Sunday. Not sure why this office building would have something going, but this would obviously raise a red flag with me, because here you had Saturday and Sunday at around 2,000 kilowatt hours, and then a holiday doubled its use. One other thing I'd like to call your attention to is the demand, which you'll see your orange maximum demand, and the maroon is the median or the average, and then your minimum is the green. Now, the one you'd be concerned about is with the orange, and you'll see over here that kW reached about 420. That is the value you'd see on your bill. So if there's any way you can shave demand, you'd start looking there. What are your demand values? What consistently are they at? And basically know what to expect. So, like I said, just some more good examples. Okay, this next type of report, this is from our Energy Expert program. This is a scorecard type report that can be emailed out to the user. This is for, you get yesterday's data today. You'll see right here we have the low temperature, over here is the high temperature, and then over in the middle is the peak and time of the peak demand you had. So it is also labeled over beneath by the gray thumbnail, which is spelled out, peak of 1022, 76 kW at 10:15 a.m. So this right here is, I think, is pretty important. If you look at it, you'll see a load shape, and then you can see that the gray block in the middle is actually meant to be the hours of operation. So if you see the left edge, that would be their startup time. They hit that perfectly. However, it looks like they did not hit the nightly edge, and it took them longer to shut down. This scorecard report is actually a report derived from several different factors. It uses a three-dimensional bin model to take current weather and current usage and compare it to historical usage and historical weather. And then once that comparison calculation is done, gives you an expected use, how much you should or are expected to use, and then your actual usage, how many kilowatt hours you actually used. Very helpful. And in that comparison gives you a rating of high, low, or okay. Uh, this next piece down here, potential peak days, this actually looks at, it uses the weather data and the weather forecast to see if you're at risk at exceeding your peak demand. Let's say if it's a warm hot spell, what have you. This basically is like a predictor to see, possibly you could reach your peak demand for the month. Below that is a comments box. Um, if you find something that is troubling or doesn't look right and you go in, investigate it, and fix it, here is where you put your findings. This person wrote, fans and boilers ran 24/7. Temperature outside was a low of 27, high of 38. The building is holding its inside temperature well. So it's good to make notes like this. Any sort of, square footage changes, lighting changes, anything operationally that would change the way your load shape is would be best to be noted in such a comment field. This next calendar summary is also from Energy Expert, and I like this one quite a bit because it gives you a good monthly glance at what's going on. You'll see all their load shapes. For the most part, they're looking pretty good. They have green and blues, and which means they're okay or low. They also have high days on Saturdays. However, one good thing about this is it tells you, just by hovering it over with your mouse, it tells you your peak time, January 1st, 2009, 9:15 a.m. Your peak value, 2290.68 kW. Your total consumption in kilowatt hours, 34,514.1. Your maximum temperature at 44 degrees Fahrenheit, and your minimum temperature is 32 degrees Fahrenheit. This is very helpful, especially if your operation is weather dependent, and it's a good indicator. This next example is of an office building using Energy Expert, and looks like they do pretty well also, except you see on the 4th, you'll see a load shape and a red flag. This means it's high. Well, if you look at all the other Sundays, you'll notice the load is flat. And you're probably wondering why, what was going on Sunday? Here's a good question to ask. Did they add an extra shift? I don't know. You're also probably wondering, well, Saturday's got those load shapes. Why isn't Saturday flat like the others? This company actually went to working a 6-day week and then went back and recalculated their baseline, their comparison baseline, to account for Saturdays being a normal workday. So that's the reason why these are not flagged. However, Sunday is still flagged because it is still abnormal to have a load shape during that day. This one here, this example of Energy Expert calendar, you'll see a whole bunch of yellow, and it's basically stems from a cold snap. Basically, the cold snap started Friday, December 4th, and it got normal load shape. However, it didn't shut down as far as it should have, and basically continued that way for the next week and a half. From what we got from the customer was that he didn't want to fight bringing that building up to temperature every day, so he left it going high. But you're also wondering, well, okay, what's with the yellow indicators, meaning out of range? These temperatures were not typical temperatures for this time of year. These will raise as yellow flags, just so you know that these temperatures are outliers and not normal, so they wouldn't know how to give you a low, high, or okay definition. But it's definitely one to bring your attention to, and you'll see now after the 14th, the cold snap is older and they're back down. Their load actually shuts down farther than normal. So anyway, we thought this was just a good indication of, an example of how people run their HVAC and not have to, shut down and restart exactly how they usually do. Okay, so we're getting towards the end. Like I said, here's the plan. Make sure you take a look at the plan and collect those energy bills. And if you're looking to get into monitoring, I encourage you to look around and see what fits you best as far as a software program, and so you can review and go over those load profiles and hopefully find some savings. So, hopefully you'll be like this guy. But anyway, it's been great presenting to you, and I appreciate you logging on and joining us today. And for now, I think we'll turn it back over to Beth.
Thank you, Will. I just wanted to thank all of you and remind you of some of the upcoming webinars that we have. In January, we have Intro to Calculating Energy Costs, and in February, we have Understanding LEDs. Also, in February is a half-day classroom seminar called Strategic Energy Management, which will bring up some of the same topics that we'll cover today, thinking about how to monitor your energy in order to affect change. So before we proceed to the question and answer portion of our webinar, I'd like to remind everyone that you can continue to submit questions to me, the host, through chat. Within a few days, we'll send you a follow-up email with a recording of the session and the PDF of the materials. At this moment, I'd like to draw everyone's attention to the poll survey, feedback survey that I just opened to the right of your screen. Please take a few moments to complete the survey during question and answers. We really value your feedback, and we'll use it to improve future webinars. And now I'd like to proceed to the question and answer portion. Will, the first question was, one of our attendees missed you explaining the how the daily and hourly load diagrams were created. Is that something you can briefly discuss?
I'm sorry. I missed part of that. Can you?
Oh, sure. He says, I missed your sharing of how the daily and hourly load diagrams were created when you were covering the load shape diagrams. Where did you get that information? How did you create that?
Oh, I got that from our eManager program example. That's just one of the few selections or different type of graphing and tooling that program does.
Okay, and I'm going to, individual who asked the question can please clarify if they want Will to cover that more. Next question we have is, how do I get historic 15-minute interval data from PGE? Can I obtain a year's worth of data, or more than that, or less than that?
You can obtain a year's worth of data if you call myself or your key customer manager or general business rep. We would be happy to look that up and get your information and see if we can get the data to you in a file.
Great. The next question is we have from a person is, how can I sign up for eManager?
You can actually just use my phone number or email address, will.miller@pgn.com, and I can send you an order form, and then we can go from there. It's pretty simple.
Great. I'm just typing in Will's email address here in the chat for anyone who would like to see it. And our next question is, how much data does the Energy Expert model need to accurately predict building performance?
Okay, this is a common question. Actually, it needs 2 weeks to start a baseline. Yeah, the program needs 2 weeks of historical data to start calculating and getting those ratings out, high, lower, okay. And basically from there on out, it grows your baseline, and ratings become more and more accurate. The optimum amount of data is probably a year's worth. Basically, if you have a year's worth of data, then from there on out, it's about as most accurate as you're going to get. But you only need 2 weeks of data to start with.
That's great. Thank you, Will. Sorry. We have one more question here. How does the daily comparison in Energy Expert work? By curve shape or total energy for the day?
Actually, Uh, um, by time and curve shape, it basically, all the 15 minutes get compared with previous 15. All the intervals get compared with previous intervals. So, like in our new eManager version coming up, you'll see a way where you'll see parts of the day that may be rated as low or okay, and then other parts may shift into the high category. So it compares it by interval to interval. I hope that answers your questions. If not, I can talk to you more offline about it, but that's pretty much how it does.
Okay, and the last question I have, unless anybody has any further questions I'd like to submit through chat, is there a charge for eManager from PGE?
Yes, there is a charge, and I believe the charge right now is $60 per month per meter, and the first meter is a $350 setup fee, and then any subsequent meter after that is a $150 setup fee, and then $60 a month fee as well. If you'd like, I can send you a price sheet, or if you want to visit on portlandgeneral.com, you'll find it on there too.
Great, thanks, Will. And we will include that information in our follow-up email to everyone.
Oh, great. Okay.
So that was our last question, and we'll stay online for a little bit in case anybody has any additional questions of Will or they'd like to chat offline. But I'd like to thank everyone for joining us today and taking the time out of your busy schedule. Thank you so much. Bye-bye.